graphing sine and cosine functions from their formulas. This is kind of the reverse of what we did yesterday. Yesterday I gave you the graph of a sine or cosine function, and your objective was to find the formula. Now I'm giving you the formula and asking you to find the graph. So how do you do that? What I've got here is a sine function, obviously with lots of transformations applied, and we're just going to graph this thing. So how does it work? What I'd recommend is that you begin by thinking about the midline of the function. So what is the midline? Let's remember that the generalized sine function, the sort of template for the sine function, is a sine omega x minus b plus m. And remember that m is what tells you the location of the midline. We can see that m is 1 here. So what does that tell us? That tells us that whatever the graph looks like, the midline is located at 1. Okay, so here's the midline, and I'm just going to make kind of a dashed horizontal line, just like that. So this is the line that's going to be running through the middle of the graph, right? Let's just keep that in mind. After you find the midline, you should find the bounce numbers. Remember that every sine and cosine function bounces between two numbers. Well, we can find those two bounce numbers. How? What you should do is think about the amplitude. Okay. Now, remember that the amplitude is equal to the absolute value of a. We can see in this case that a is -3, so the amplitude would be the absolute value of -3, in other words, 3. Now, if you remember, the amplitude gives you the distance from the midline to the peak of the wave. In other words, the distance from this midline to the top bounce number is going to be the amplitude, 3. So if I start at the midline and go up by 3 units, 1, 2, 3, that puts me at 4, then this will be the top bounce number, okay? And if I start at the midline and go down by 3 units, 1, 2, 3, that puts me at -2, that will be the bottom bounce number. So whatever the graph looks like, it is going to bounce between -2 and 4. And you can see that this makes sense, right? You can imagine the wave sort of sitting here, and the amplitude will be distance from the midline to the peak, which is 3. Okay. Now what we need to do is think about the beginning of the cycle. Where does the cycle begin? Remember that the beginning of the cycle is given by b, right here. So that means that b is going to be pi. So the beginning of the cycle is going to be sitting at pi. Let's say that that's right here, okay? So that's where the beginning of my cycle is. Now, what I'd like to do is figure out the end of my cycle, and perhaps figure out, like, the midpoint of my cycle as well. Now, if this is where the cycle begins, then to find out where it ends, I need to know the period. Remember, the period is the length of one full cycle. So let's find the period. Remember, it's given by this formula. P is equal to 2 pi over omega. That would be 2 pi over, what is omega in this case? It seems like it's 8. So that's 2 pi over 8, which reduces to pi over 4. So that's the period, right? Which means that if I start at pi and then I move pi over 4 units to the right, that will put me at the end of the cycle, because the cycle is pi over 4 units long. So where exactly does that put me? If I take pi and I move pi over 4 units to the right, where do I land? Well, to find out, you have to take pi and add pi over 4. So let's do that. So if I take pi and then add pi over 4, well, to combine these two things, I need common denominators. So that's like 4 pi over 4 plus pi over 4, which gives me 5 pi over 4. So that's where the end of my cycle is going to be. So let's say that that's right here. One thing you'll notice is that I'm really not worrying about whether or not this is to scale. Like, if pi is right here, is this really where 5 pi over 4 should be? no, I think if I were drawing it to scale, then it would be a lot closer to over here. But I'm not really worried about the scale. I just want to get the labels on the x-axis correct. So, I have the beginning of my cycle, I have the end, but as we'll see, it's also convenient to figure out where the middle of the cycle is. We'll see why that's true in a moment. So how can we find the middle of the cycle? There's a couple ways of doing it. The middle of the cycle will be halfway between these 2 points. You could take these two numbers, add them together, and then divide by 2. That would give you the midpoint of these two values. Or you could say to yourself, the halfway point, the middle of the cycle, is going to be where? Well, all you have to do is take pi and then add half of a period, right? I mean, this whole distance here is 1 period, so if I add half a period, that will land me at the halfway point. So I think that's what I'll do. So I'm going to take pi, and I'm going to add 1/2 the period. We saw that the period was pi over 4, so if I add half the period, well, half of pi over 4 is pi over 8. Okay, so that's pi plus half the period. So to combine these, I need common denominators again. This is like 8 pi over 8 plus pi over 8, which is going to give me 9 pi over 8. So that's the middle of my cycle. So I'll go ahead and add that to my graph, 9 pi over 8. All right, so with all of these things in mind, we're kind of ready to draw the graph. But we have to now be careful, right? What exactly are we drawing here? Well, we're drawing a sine function, right? We're drawing a sine graph. And the basic idea is that you should be thinking about what one cycle of the basic sine function looks like. And that's kind of what you're going to be copying here. So let's just temporarily recall what one cycle of the basic parent sine function looks like. So what does one cycle of just plain old y equals sine of x look like? Well, of course, it begins at 0. The bounce numbers are negative and positive 1. And what happens? If you remember, it goes up, hits that top bounce number, comes back down, hits the bottom bounce number, and then comes back up, right? That's one full cycle of the basic sine function. Now, what I sort of need to do is just take this cycle and copy it here. I should emphasize, maybe I haven't said this yet, and I want to make it clear, I'm only going to graph one cycle of this function. You know that there are many, many cycles, but I'm only going to graph one of them. So we need to basically copy this one cycle here in our graph, except it's probably going to be modified in some ways. So how do you do that? How do you sort of translate this thing over here? The big idea is to recognize a couple of things. First of all, there are some sort of key important points in the basic sine graph. These 3 points right here, the beginning point, the middle point, and the end point. I want you to notice that for the sine function, they all sit on the midline, right? The midline of the basic sine function is right here, and all 3 of these points sit on the midline. So we can use that information over here. Our 3 points over here are going to sit at the beginning, middle, and end, and they're going to sit on the midline. So beginning, middle, and end sitting on the midline. Now, all we have to do is sort of duplicate this wave graph here, although I want to point something out. The a value that we have here is negative, right? It's a -3, which indicates that our graph is going to be upside down compared to the basic sine graph. Now, the basic sine graph begins by going up as you move to the right. But since our graph is upside down, our graph is actually going to be moving down as you start the graph. So let's draw it carefully. The graph is going to go down. It's going to go all the way down to that bottom bounce number at -2, and then come back up and cross this point. Then it's going to go up all the way up to the top bounce number and come back down to this ending point at 5 pi over 4. So I have all the way down, goes up, hits that top bounce number 4, comes back down. So that's one cycle of our function, and that's all that I'm looking for. If you really wanted to know the coordinates of this point right here, you could find it. Obviously the y-coordinate is -2. As far as the x-coordinate, if you think about it, it's going to be halfway in between these two values. So if you wanted, you could find the coordinates of that point, but I'm not too interested in that. So let's just do one more example. Let's do a cosine function. So let's say y is equal to 2 cosine 4 of theta minus, let's say plus pi over 3 minus 5. All right, so it's going to be the same thing that we did before, and so I'm going to do it a bit more quickly this time. Let's start, what did I start with last time? I started with the midline, right, which is given by this number here. That's -5. So my midline is at -5, so I'm going to draw that line right here at -5. Then I find the bounce numbers using the amplitude. The amplitude, of course, is 2 in this case. So if I start at the midline and go up by 2, that's my top bounce number. That's going to be -3. And if I go down by 2 units from the midline, that's going to give me my bottom bounce number, -7. All right. Then I need to find the beginning of my cycle. So that's, of course, given by b. Notice because of the plus, b is actually -pi/3. Remember, b is sort of the opposite of what it looks like. That means my cycle begins at -pi/3. So let's just pretend that that's somewhere over here. I don't really know exactly where it is, but I don't care about the scaling too much. Now what I want to do is find the end of my cycle. So how do I find the end of my cycle? What I do is I start at -pi/3, and then I add one full period to -pi/3. So I have to find the period. Well, the period, of course, is given by 2 pi over omega, which is 2 pi over, well, omega here is certainly 4. So that's 2 pi over 4, which is pi over 2. So the period is pi over 2. So what's the end of my cycle? Let's see. If I take -pi/3 and I add pi over 2, I need common denominators. That's -2 pi over 6 plus 3 pi over 6, which is equal to +1 pi over 6. Sorry, that got kind of cut off. So there's my calculation there. So this thing right here, that's the end of my cycle. So that's going to be a positive number. Let's say it's maybe here. So there's pi over 6. And then I also want to find the middle of my cycle, right? Now, the middle of the cycle can be found in a few different ways. You could take this number and add half the period, right? That would certainly work. Or you could add these two numbers together and divide by 2. I'll just take the -pi/3 and add half the period. Now, the period is pi over 2, so half of that is pi over 4. So what does this give me? Well, I need common denominators, so that's going to be -4 pi over 12 plus 3 pi over 12, and that gives me -pi over 12. So that is the middle of my cycle, -pi over 12. Okay, so that's kind of all the information that I need. Now I'm ready to draw the graph. Now what I have to do is think about the basic parent cosine function, right? This is a cosine function, so I need to think, what does one cycle of the basic cosine function look like? If you remember, the basic cosine function looks like this. Of course, it's got bounce numbers at -1 and +1. The midline is the x-axis, and it starts at the top, right? So it goes like this, it comes down, and then it comes back up. And that is one cycle of the basic cosine function, y equals cosine x. Now, what I'm going to do, very similar to what I did in the sine graph, is I've got these 3 interesting points, beginning, middle, and end. And I just need to kind of transfer them to my graph. I have to say, where are they? You should always ask yourself at this point, is the graph upside down? Because the 2 is positive, it's not upside down, which means that my graph is going to sort of start high and then go low. All right, so where are these 3 points? If you notice, this point here in the basic cosine graph, it's at the beginning of the cycle, and it is at the top bounce number. So I go to my graph, beginning of the cycle, at the top bounce number. So here's the top bounce number, -3, so right there. This next point here is in the middle of my cycle at the bottom bounce number. So middle of my cycle at -π/12, bottom bounce number at -7, so that's right here. And then finally, this point here is at the end of my cycle at the top bounce number. So end of my cycle, that's at π/6, at the top bounce number, which is at -3. And then I can use these 3 points as kind of a guide for what the graph looks like. So something like this. Okay? And that's it. Just notice that if the 2 were negative, then this graph would be upside down. Instead, it would sort of look like this.
Excuse me.
Right? But otherwise, that's the only thing. Okay.